Today we're going to be looking at lesson 1.3, which is solving equations. So we're still dealing with equations with variables on both sides. So in the first lesson, you looked at some pretty simple equations. So we were looking at things like, just x plus 3 is equal to 10. So we were looking at some pretty basic ones. And then in lesson 1.2, we got into a little bit more complicated. So maybe they did like a 4x minus 6 is equal to like 9 or something. Now in this one, you'll notice that the variable's on both sides, okay? So the essential question for our lesson is how can you solve an equation that has variables on both sides? And hopefully what you're saying is, first, you want to get the variables to one side. So let's say variables to one side. And then second, obviously we want to put our numbers to the other side. And then we want our variables to be completely alone. So let's just say variable alone, meaning no coefficient. So we can't have this front number out front, okay? And if you notice, there's 4 problems on this page, and I apologize if some of these, sometimes on the projection, it's hard to see if that's a negative sign, or sometimes it's hard to see if that's a plus or if that's an equal sign on the projection. The original copy of these notes is uploaded online, so always feel free to reference that if need be, okay? So on number 1, we're trying to get this x alone. So my suggestion would be to move this negative 3x to the other side. So I always want to use the opposite operation. So I'm going to go ahead and add 3x to both sides. And so on the left here, I'm just going to get a 12 because these are going to cancel. And on the right, if I do negative 6 plus 3, I get negative 3. And so notice I have my numbers on one side and I have my variable on the other. And now I just need to get rid of this coefficient. So because it's multiplication, we're going to just divide it off. So on the left, we'll have negative 4, and then the front ones will cancel, and we just have our variable. And then we're all done. So on the same number 2, notice on this one, we still have the variables on opposite sides, but we also have numbers. So really, this is up to you. And since I'm all alone here, I get to make the decision of what I want to do first, but know that there is another option. If it was me, I always like to go towards the bigger. So I would move the smaller variable towards the bigger. But you could easily go the other way. It won't make one bit of difference. So this is a positive 3. And so notice what I'm doing is subtracting. And in today's lesson, I'm going to take this one step at a time. But definitely feel free, if you know how to skip steps, maybe you would move the 25 at the same time. But for today's lesson, I'm just going to take it nice and slow. All right, I have my variable on the right. Now I need to get rid of this number to the other side. So because it's a plus, I always do the opposite. So notice how I'm subtracting. So when I subtract, I get 20 on the left. And once again, now I've gotten my variable kind of isolated. I just need to get rid of that coefficient. And notice how I'm always using the opposite. So this was multiplication, so I use division. So I have 20 divided by 5, which is 4. And then my variable, notice those cancel. And so I have 4, okay? Now, if you notice, the next 2 problems have one extra little step because it's the parentheses here. So we're going to use the distributive property. So we're going to take 3/4 times 48, and we're going to go 3/4 times 16. Now, if you have a graphing calculator, just kind of want to start to show you some things here. This is the older style graphing calculator, but even the newer ones still probably work the best this way. So for today's video, I'm just going to show you this way. If you want to do 3/4, what you're going to need to do is you're going to need to put it in parentheses. You can't just go 3 divided by 4 like that and then try to do times because it's going to get it confused. So what we do is we use these little parenthesis keys right here, right above the 8 and the 9. So we're going to go parenthesis. And then we're just going to go 3 divided by. So see my fingers right by the division? Divided by 4. And then notice I'm going to close it off. Now I actually don't have to do times 48. I can actually not put this multiplication sign here, or I can. It really doesn't make a difference. And then we'll hit enter. So notice then that's going to be a 36. So I'll just kind of show you one more time. I'm going to take 3/4, so see how I'm putting it in parentheses, and then I'm going to times it by a negative 16. And notice I get a negative 12, but remember there is a variable behind this one. So all I've done is I've just used the distributive property, but I just kind of wanted to show you that and what to do with fractions. For those of you that the graphing calculator is new, the more you practice with it, the more you'll get to kind of understand its features. All right, and then on the right side, we're going to also use the distributive property, but I don't have a fraction here, so I'm just going to go 4 times 4, and then 4 times 2x, and there we go. Now, if you notice my variables, again, I've got one on each side, which is the lesson of today. But what I like to do, and you can go to whichever side, I like to go towards the one that's bigger and positive. So what I'm going to do is I'm going to move this negative 12 over here because then it's going to turn positive. But it's up to you. It really does not make a difference. I promise you, you will get the same answer. So on the left, I've got a 36. And on the right, I have 16 plus 20x. And then now I'm going to move my 16. And remember, the 16 is positive, so we're always doing the opposite. So that's going to become 20, and then those cancel 20x. And then now I'm just going to divide off the coefficient. And I know that kind of looks funny, but 20 divided by 20 is just 1. So my answer is just simply 1. And remember, you can always check your work. So if you don't trust yourself, or you're not sure if it doesn't look right, let's type this back in. So we're going to go 3/4 in parentheses, and then parenthesis, 48 minus 16. Now, I know that you know what times 1 is in your head, but let's say this was a different number. So you could always just, whatever that number is, plug it in there. And we'll hit enter. And we're going to do the same thing on the right side. So we'll type it in on the right side. And again, I know that you know what 2 times 1 is, but if it was a different number and you might not know it, or if it was like a decimal and it was harder, it's a good way to check. So because my left and my right are the same answer, I know I've done my work correctly. So why don't you pause the video here and why don't you try number 4 on your own? Okay, hopefully you paused it. I'm going to try to go through this one pretty quickly. There is one additional step if you notice right here. So at any time, if I'm going too fast, please feel free to pause and rewind and go over it again. So I'm going to go 8 times 2, which is 16. And then we're going to go 8 times 3, which is 24. Got to make sure, it's been the summer. I want to make sure I'm doing this right. And now notice I do not distribute the 8 to the negative r. So notice how that stays the same. And then I'm going to distribute the 3, so 3 times 3, and then 3 times 2. Now, if you notice on my left side, I have a 16r and a minus r. Do you notice how those are on the same side? See my equal sign here? They're on the same side. So I do not make this a plus r when I combine. I just simply do 16 minus 1. And so that becomes a 15r. So I'm putting these two together. Now the minus 24 doesn't change, and the right side doesn't change. Now I've got a variable on each side, and this is where you would need to decide which way you like to go. Again, I like to go towards the larger one. So I'm going to move this 9 to the other side. So 15 minus 9, and the negative 24 and the 6 are not changing. And now I'm going to move the 24 to the other side. And so I have 6r is equal to 30. And I'm kind of at the bottom of my paper here, so I apologize. I'm getting rid of that coefficient, so I'm just dividing off the 6. And so those are going to cancel, and 30 divided by 6 is 5. And again, you can always plug that back in to check it. All right, we only have a few more here, so let's turn to the other page. Notice there's just 3 more. And on this one, notice the very, very first words at the top. It says special solutions. Not all equations work. Not all equations have one solution. So notice it says an equation that is true for all values of the variable is an identity and has infinitely many solutions. So if it's true for all, if it's true for everything, and you're going to see this in a minute, it will have infinitely many solutions. Now be careful in using the word infinity. Infinity means something different, and we will hopefully be getting into this in class. But infinity really kind of means everything. And this is telling you not everything works, but many things work. So be really careful. That word can be very tricky, okay? Now the second one, so let's put like a 1 here. So the second one is when an equation is not true. If it's not true for any value of the variable, it has no solution. So that's another option. And then the third option is just x equals a number. So when we're solving an equation, we really have 3 possible ways our answer could come out. And if I didn't tell you ahead of time, this looks fairly normal. This looks like a fairly normal problem. But when we get into this problem, you're going to see kind of a little trick. So let's go ahead and distribute. So we're going to go 6 times 4 and 6 times 12. Now I don't know that off my head, so I'm going to type that in my calculator, which is okay. You'll feel free to use your calculator. And then we're going to go 8 times 3, which is 24. And we're going to go 8 times 14, which again, I don't know that off the top of my head, so I'm typing it into my calculator. And look at that. Look at my variable. Do you see my variable there? They're exactly the same. So it really doesn't matter which one I move. Let's say I'm going to move this one to the right. So I'm going to move this way. I'm going to subtract the 24s. And what you should notice is my variable cancels and I have a 72. My variable cancels and I have a negative 112. Is that equal? No. So because it's not equal, we say that is a no solution. See how it says it's not true. So we would say no solution. But again, at the beginning, this problem didn't really look unique. So these problems were going to be mixed into your homework assignment, and you're really not going to know until you work them out, okay? So if you want to pause it here and try number 6, feel free. Okay, hopefully you tried it. Now on the left-hand side, there's nothing to do, so I'm just going to recopy it. And on the right, I'm going to go ahead and distribute. So that would be 8 times 2f and 8 times 3. Uh-oh, look at that. The left and the right are exactly the same. So watch. If I subtract 16f, it doesn't really matter which way I go again because notice they're the same. I'm going to get 24 is equal to 24. And that is a true statement. Now again, it does not mean any number works. It just means there's infinitely many. So let's just write that. Infinitely many solutions. And you can kind of abbreviate a little bit, but go ahead and just fill that in. And then there's one last problem. Notice I've already given you an example of each one here. So why don't you try this last one and just see what happens. Okay, hopefully you paused it and tried. Let me go ahead and distribute. Half of 10, half of 12, a third of 15, a third of 15 again. That was kind of easy. Look at that. Look at my variables. They're different, aren't they? So this is not going to be one of the unique ones. Do you see how it was just kind of mixed in? So I'm going to move. I like to go towards my bigger one, so notice I'm going to move towards the larger one. So I get 5, and then 6 minus 5 is essentially 1, but we don't have to write the 1. And then over here we have 5. And now I'm going to move this number to the other side. So we're going to subtract 5, and we're going to have n equals, and then what's 5 minus 5? 0. It's okay to have 0 as an answer. Don't think that you did something wrong. That's okay. And that concludes lesson 1.3.